Okay, starting lesson 5.1b, using fundamental identities. Okay, once again, you have to use that yellow sheet with all the identities. Get familiar with them. Okay, so starting off, part A, 1 minus cosine squared x. Alright, it says to factor. Okay, so 1 is the same thing as 1 squared, and doesn't this look something like this? This is just a little side note. X squared minus y squared, what is that? That's a difference of squares. We have the same structure here. So let's apply a difference of squares. 1 plus cosine of x times 1 minus cosine of x. Alright, and that's it. We factored it. Done. Part B. Okay, doesn't this structure look familiar? Okay, the A in this case is 4, the B here is 1, and the C is -3. The X's are replaced with tangents, okay, but everything's the same. All right, it's a quadratic structure. So we could just say x equals tangent theta. All right, we could rewrite this as 4x squared plus x minus 3. Now this should look more familiar. Okay, so we're going to use the big X with grouping method. You may have your own method. Feel free to use your own. All right, but I need to find two numbers that add up to 1 and multiply to give me -12. All right, so now I have 4x squared. I take that middle term, I break it up using these two values. Then I have my constant. Okay, now I apply the grouping method. All right, out of the first group I could factor out x. Out of the second group I could factor out a 1. And what I've left over, x plus 1. Alrighty, and now we're not done. We have factored everything correctly, but what is x actually in this problem? It's tangent. So let's substitute that back in. 4 tangent of theta minus 3 times tangent theta plus 1. So this is just regular algebra with a little trig twist in it. Alright, so it shouldn't be too difficult to work out. Alright, one more example, part C. Let's see here, we have cosecant squared x minus cotangent x minus 3. Alright, I have two different trig functions here. Alright, first thing you want to do is make sure you have the same trig function whenever possible. That always makes life more simple. I could replace this using a Pythagorean identity. So that's equal to 1 plus cotangent squared x. Then I have minus cotangent x. Then I have minus 3. Alright, and now I have reordering everything. I have this. Or I could use the big X method now. You don't have to substitute if you already can see what's going on. This is a quadratic structure. This is like x squared, and this is like x. So here's my coefficients 1. This one's -1. So I need to find two numbers that add up to -1 and multiply to give me -2. And going back to part B real quick. To get this number down here, you multiply 4 times -3. I think I forgot to state that. Alright, going back to part C though, the two numbers that work are 1 and -2. Okay, so I could break it up now. My x in this case is cotangent, so I write cotangent of x plus 1, and then cotangent of x minus 2. Okay, let's go on to some more examples. Alright, simplify this expression. Alright, now this is why I keep saying get familiar with your yellow sheet and all the identities, because the more familiar you are with them, the easier it will be to see what you're supposed to do here. So I have cosecant, cosine, cotangent. Now you just have to ask yourself, like, how do these trig functions relate to one another? So cotangent, what does it have in it? Well, we know the reciprocal is 1 over tangent. That doesn't help us in this case. There's the quotient identity. That's cosine over sine. Okay, so let's apply that, because then that'll narrow down our trig functions from 2 to 3, or 3 to 2. All right, so cotangent is cosine of t over sine of t. All right, and multiplying those, I have cosecant of t minus cosine squared t over sine t. Well, let me correct myself. We still have 3 trig functions. Okay, but what are we going to do? We'll notice that if I apply the reciprocal function here, I have 1 over sine of t. And then as soon as you recognize that, then life should become a bit easier with this problem. Okay, now that I have a common denominator, subtract the numerators. All right, just bringing this up here. All right, and now looking at the top, one identity should come to mind, the Pythagorean identity. And we can apply that now. We get sine squared of t replaces 1 minus cosine squared t. All right, so now one of the signs on the bottom cancels out with one of the signs on top, leaving you with sine of t. Done. All right, example 3. Okay, we have 2 fractions we're adding up. And when you're working with fractions, what do you need? A common denominator. So yes, we have to multiply the denominators by each other. Okay, and let me shift everything over here a bit. Okay, and I have 1 minus sine theta times 1 minus sine theta. Okay, so on the top I get 1 minus sine theta plus 1 plus sine theta. And on the bottom, okay, I'm multiplying conjugates, okay, minus, plus. So whenever you multiply conjugates, you multiply the first terms and you multiply the last terms. Okay, so they just happen to be conjugates of one another. That works out nicely. Okay, what's the next part? Well, let's simplify here. So the signs cancel out. That's pretty nice. Then I have 2 over 1 minus sine squared theta. And looking at this, we can apply the Pythagorean identity. So we get 2 over cosine squared theta. And applying the reciprocal identity, we get 2 secant squared theta. All right, done with that one. All right, and as time goes on, the more examples you go through and the more familiar you get with identities, the easier and easier these problems become. Example 4, simplify. Okay, what are we going to do here? All right, we got this difference on the bottom. All right, whenever you want to get rid of a difference like that, one strategy you can utilize is to multiply by the conjugate. Because then you'll end up with something squared on the bottom. And when something's squared, then you could tap into the Pythagorean identity possibly to help simplify things. Okay, so we have cosine squared y times 1 plus sine y all over 1 minus sine squared y. And let's see what we have now. I have cosine squared y, 1 plus sine y. On the bottom, I can replace this. Applying the Pythagorean identity, I can replace it with cosine squared y. Okay, that's why it sometimes is beneficial not to immediately distribute, because if you had done that, then you wouldn't see that right now. We can just cancel these out. So before you distribute, wait to see if you could cancel out the pieces first. All right, and then I'm left with 1 plus sine of y. All right, and then nothing else we could do with that. Done. All right, example 4, use the substitution. X equals 5 sine theta. All right, they provide a restriction here to write the square root of 25 minus x squared as a trig function of theta. Okay, well, we don't really have to worry about this right now. Let's just do some substitution. Square root of 25 minus 5 sine theta, this whole thing squared. So I get 25 minus 25 sine squared theta. Okay, and then what can I do now? You could factor. All right, and then now something else should stand out. 25 times, applying the Pythagorean identity, we have cosine squared theta. Okay, and now I can take the square root of both components now, since it's a product, meaning I'm multiplying them. So, oh, there's no square root anymore. We don't need a square root. We're done with that. So we have 5 cosine theta. And that's all there is to that. We're done. And the last one. Okay, this looks a bit crazy. Don't freak out though, it's just absolute values. So here I have a sum of logs. You can rewrite a sum of logs as a product. Secant theta, cotangent theta. Okay, just a little reminder on the side. Ln of x plus ln of y is equal to ln of x times y. All right, that's a logarithm property. Could go back to your yellow sheet to refresh your memory with those. All right, but here I have natural log of secant theta, cotangent theta. How can I simplify these? All right, so start looking at your identities, seeing how you could relate some of the functions, and then maybe this will stand out. I can replace secant with 1 over cosine theta times cotangent, which is cosine theta over sine theta. Okay? And you only get good at these problems by, working on them on a daily basis. So now we see that these functions cancel out, and what originally looked like a complex problem actually turns into a very simple one. All right, now I can apply the reciprocal identity, and I get natural log of cosecant theta. All right, that's all there is to that. We are done. All right, begin the assignment at the bottom of the web page. If you have any questions, please make sure to ask. All right, and don't push off your assignments, especially for this chapter. Chip away at it day by day. So within the next couple of days, these problems will start to become really simple to do. Otherwise, you're going to have a difficult time. All right.